Now for a problem like number 5, what we're trying to do is figure out what the sign of delta S is. Now the problem here is predicated on this fact. We know that as far as entropy goes, gases have more entropy than aqueous ions, than pure liquids like water or bromine or something like that, and then that's greater than solids. So solids really aren't going to play much of a role here when we're determining, there's a solid there, when we're trying to determine what effect this is going to have on the entropy. But you do notice that we do have some aqueous ions here, here, and here. These are all aqueous ions. As such, they split up into ions. So the first mission here is to determine how many ions these split into, and then we can figure out the difference between the ions on each side. You see, that's what the question's asking for. Determine the difference in relevant particles. In this case, it's aqueous ions. To allow for determination of delta S. So for Na2CO3, I'm going to draw a picture of that. And if I will put the charges on. We don't really need to though, because we just need to figure out how many ions we have here. That's 3 ions. CaCl2. That's 3 ions as well. So on the reactant side, we have 6 ions in total. Now on the product side, we've got CaCO3 solid, which is effectively 0 ions, because it doesn't split into ions. Why is that? Because it's a solid. Because it's a solid, it doesn't split into ions. The 2 NaCl, if I drew a picture of that, it would look like this. And that's a total of 4 ions. Now the actual formula for entropy is going to be the sum of the entropy of the products minus the sum of the entropy of the reactants. Now the entropy of the products here is going to be determined by these 4 ions. So it's going to be 4 minus 6. And the answer here is going to be -2. I know that's not an answer here, but these answers do continue downwards to 3, 2, 1, 0, -1, -2, all the way down to -9 or greater. But the answer here is going to be -2, which represents the difference in ions going from the products to the reactants. From a more global point of view, you could argue that we have much more entropy on the reactant side than we do the product side. So what that means is there's been a decrease in entropy going from the reactants to the products, which makes sense as why we're getting a negative value here for the difference between the ions.